how to build effective agents. So this is yet another video of mine about principles related to building AI agents that are reliable, which is a huge challenge. If anyone tells you otherwise, they are either misleading you or they don't understand what reliable and production ready agents are. Anyway, this topic is important enough, and this is basically what the channel is about: building reliable production ready automations. So I wanted to share with you this excellent article that was published by the Anthropic team. I'm jumping directly into the parts that I think are most interesting. I don't think that the introductory context is relevant, but it's mostly understanding the principles as they are sharing here based on their observation. I'm pretty much going to read what they wrote over here and double click or emphasize whenever I feel it's necessary. Let's just go over these principles very fast and see how it goes. So first of all, here are a few important lessons regarding how to build reliable agents. So first of all, you must understand the effect of your prompts, and you must think as if you're an agent. And many people say that you should treat your agent as if he was an intern. So think about all the mistakes that he can do. Think about all the context that you need to provide. Think about all the guardrails that you need to give him. Treat him as if he's an intern or a human being, and the prompt should be written as if you're guiding an intern. So this is the first point. The second point is regarding the orchestrator, which is probably the most, I wouldn't say the most important, but it's a very important agent in the multi-agent conversation. So basically what they are saying, in our system, the lead agent, the orchestrator, decomposes queries into subtasks and describes them to sub-agents. Each sub-agent needs an objective, an output form, guidance on the tools and sources to use, and clear task boundaries. Without detailed descriptions, agents duplicate work, leave gaps, or fail to find necessary information. We're starting by allowing the lead agent to give simple, short instructions like research the semiconductor shortage, but they found that these instructions often were vague enough that the sub-agents misunderstood them and kind of made the exact searches like other agents, for example. So, for instance, one sub-agent explored the 2021 automotive chip crisis, while two others duplicated work investigating current 2025 supply chains without an effective division of labor. So you must teach the orchestrator how to give guidance to the other sub-agents. Next is scale effort to query complexity. This is a very interesting one. So agents struggle to judge appropriate effort for different tasks. So we embedded scaling rules in the prompts. Simple fact-finding, for example, requires just one agent with 3 to 10 tool calls. Direct comparison might need 2 to 4 sub-agents with 10 to 15 calls each, and complex research might use more than 10 sub-agents with clearly divided responsibilities. So they provided these explicit guidelines to the orchestrator and in general in the flow. And these guidelines help the lead agent allocate resources efficiently and prevent overinvestment in simple queries, which was a common failure mode in early versions that they saw. Next is tool design and selection are critical. It's pretty straightforward, but they have some nuances here that we need to go over. So agent tool interfaces are as critical as human-computer interfaces. Using the right tool is efficient, often it's strictly necessary. For instance, an agent searching the web for context that only exists in Slack is doomed from the start. So basically what they're saying here, make sure that you have very detailed descriptions of the tools so the agents know which tool to choose and they don't go down a wrong path. So as I wrote here, bad tool descriptions can send down a completely wrong path. So each tool needs a distinct purpose and a clear description. Next one, also interesting. Let agents improve themselves. So we found that Claude 4 models can be excellent prompt engineers. When given a prompt and a failure mode, they are able to diagnose why the agent is failing and suggest improvements. We even created a tool testing agent, which is very interesting. When given a flawed MCP tool, it attempts to use the tool and then rewrites the tool description to avoid failures. By testing the tool dozens of times, this agent found key nuances and bugs, and basically this process for improving the tool resulted in a 40% decrease in task completion time for future agent, which is kind of mind-blowing. Then start wide, then narrow down. Let's skip this guided thinking process. So this is important in terms of reasoning or thinking agents. So basically we have the extending thinking mode, which leads Claude to output additional tokens in a visible thinking process. And this can serve as a scratch pad, and it will help you to analyze what's going on and the chain of thought that the agent is using. Now, the lead agent uses thinking to plan its approach, assessing which tool fit the task, determining query complexity and sub-agent count, and also defining each sub-agent role. Now, their testing showed that extending thinking improved instruction following, reasoning, and efficiency. So this is important. Parallel tool calling transforms speed and performance. Obviously, when you use parallel processes for spinning off sub-agents and tool calling, it's obviously going to speed up the whole process. Let's move on. Now they are talking a bit about evaluations, which I covered a lot in the recent videos, and this is also very interesting. So start evaluating immediately with small samples. We discussed this like with the eval-driven development. So some people say that you should start with the evals and only afterwards create the agent. Now let's see what they are saying. So in early agent development, changes tend to have dramatic impact because there's an abundance in low-hanging fruits. A prompt tweak might boost success rates from 30 to 80% as an example. With effect sizes this large, you can spot changes with just a few test cases. So they started with a set of about 20 queries representing real usage patterns, and testing these queries often allowed us to clearly see the impact of changes. So basically they had the evals from the get-go. Next, using LLM as a judge evaluation scales when done correctly. So they say research outputs are difficult to evaluate programmatically since they are free-form text and rarely have a single correct answer. LLMs are a natural fit for grading output. We used LLM as a judge that evaluated each output against criteria in rubric. So for example, factual accuracy, citation accuracy, source quality, etc. They experimented with multiple judges to evaluate each component, but found that a single LLM call with a single prompt outputting scores from 1 to 0 and a pass-fail grade was the most consistent and aligned with human judgment, which afterwards they also share human judgment. So basically, when the LLM as a judge doesn't work and the code cannot find what went wrong, it's also very important to have a human on the loop and analyzing the traces and seeing what can be improved. What else? So yeah, here just a few finishing thoughts. So obviously agents are stateful and error compound. So agents can run for long periods of time, maintaining state across many tool calls. This means we need to durably execute code and handle errors along the way. Without effective mitigations, minor system failures at the beginning can be catastrophic for agents. When errors occur, we can't just restart from the beginning. Restarts are expensive and frustrating for users. Instead, they build systems that can resume from where the agent was when the error occurred. So basically, checkpoints. We also use the model's intelligence to handle issues gracefully. For instance, letting the agent know when a tool is failing, and letting it adapt works surprisingly well. And they combine the adaptability of AI agents built on cloud with deterministic safeguards like retry logic and regular checkpoints. Here they are saying debugging benefits from new approaches. I'm going to skip this. Deployment needs careful coordination, obviously. Synchronous execution creates bottlenecks, so there is an upside for running in parallel, but on the other hand, it might create coordination issues. So this needs to be taken into account. I guess it's more of an advanced topic, but still I think it's important just to have this in mind. And in terms of the conclusion, so when building AI agents, the last mile often becomes most of the journey. So it's easy to build an AI agent for a demo or for a YouTube video, but if you want to build them in a reliable manner and you want them to be relevant for production, it's going to take a ton of work, especially at the edges. So code bases that work on developer machines require significant engineering to become reliable production systems. The compound nature of errors in agentic systems means that minor issues for traditional software can derail agent entirely. Okay, we said this. Despite these challenges, multi-agent systems have proven valuable for open-ended research tasks. So this is a very important distinction. For open-ended tasks, giving more freedom to the agent makes a lot of sense. But if you want something that is more reliable and predictable, you probably need to use more code, more guardrails, more assertions, etc. Let me see. Yeah, I think that's pretty much it for this one. Over here, they have a few more points that they shared in the appendix, but I think we covered the gist. I don't feel that there is anything new here. If you've been trying to build AI agents and you've been reading research, not much new, but this is very interesting to see the challenges that Anthropic, which are at the frontier, the challenges that they are encountering and how they approach this, and also learning the jargons that they are using and what are the methods that they are developing in-house, because what these guys are doing is probably what all the other builders should experiment with as well. So that's it for today. I hope you enjoyed this short video about building multi-agent systems, best practices or principles to implement. If you enjoyed this video, please like and subscribe. Leave a comment below with your feedback and insights regarding your experiments in building AI agents. And until next time, keep on automating.